Solving systems of equations by substitution. We're asked to solve this system of equations, and in the previous video we learned how to use graphing to solve a system of equations. We would have graphed both of these lines since they're in slope-intercept form, and wherever they intersect we call that point the solution to the system of equation because it lies on both lines. In this video, we'll learn how to solve a system of equations by using an algebraic method that does not require us to graph the lines. So here, both of these expressions are equal to y. So let's set 2x minus 5 equal to 5x plus 7. And now let's solve for x. Subtract 5x from both sides and add 5 to both sides. Let's divide by -3, and we get x equals -4. Now that is the x-coordinate of my solution. We can substitute that value for x into either equation. I'll pick the top one. We'll substitute -4 in place of x. Let's multiply and then subtract. -8 minus 5, that's -13. So let's put our solution in x, y ordered pair form. Our solution is -4, -13. If I were to have graphed these two lines, that is the place at which both lines would have intersected. Here's another example. Here you'll notice the equations are not in slope-intercept form. However, one of the equations is solved in terms of x. So I want to take that expression for x that I have in red text, the -2y plus 11, and I want to substitute that in place of x in that top equation. And we're going to need to distribute the 12 into the parentheses. And we need to combine like terms and also subtract 132 from both sides. Let's divide both sides of the equation by -30. And here I have the y-coordinate of my solution. Now to get the x-coordinate, I can substitute it into either given equation. Hopefully you'll agree it makes more sense to substitute it into the bottom equation since it's already solved for x. So that's -8 plus 11, or x equals 3. So my ordered pair now, remember it's always x, y, is 3, 4. That is the solution to the system of equations. So remember how we solved this, or how we approached this problem, is we used the equation that was already solved in terms of one of the variables. I substituted that expression into the other equation. All right, example 3, I'm asked to solve a system of equations neither of which is solved explicitly for x or y. So we have to make a decision which equation is going to be easier to work with that will allow me to solve for either x or y. Hopefully you'll agree the top equation. And to solve for y, I simply subtract 2x from both sides. Now I'm going to substitute that expression, -2x minus 4, into y in the second equation. And here I can solve this equation for x by distributing -2. And now let's combine like terms and subtract 8 from both sides. And we get x equals -1. Now I can take that value for x and substitute it into either of the two given equations, but I'd rather substitute it into the equation I've already written in terms of y. So let's substitute -1 in place of x. 2 minus 4 is -2. So the solution to this system of equations is -1, -2. So now, what if we had a word problem? How would we use substitution? A school play charged adults $8 and students $5 for tickets. There were 75 people who attended the play. The box office collected $444. How many adults, we can call adults X, and how many students, we'll call students Y, attended the play? So from the given information, because 75 people attended, we can write our first equation. And from the first sentence and the third sentence, we'll write our second equation. And just like before, we want to choose one of those two equations and solve explicitly for X or Y. I'll choose the top equation and I'll solve it for Y. Now I'll take that value, that expression, which I have in red, and I'll substitute it in place of Y in the second equation. And I'll use my algebra skills and distribute 5 inside the parentheses. I'll combine like terms and subtract 375 from both sides, and I get X equals 23. So I want to think, what does that mean in terms of the context of the problem? 23 has a significance. 23 adult tickets were sold. So to find out how many student tickets were sold, we can use the equation I've already written for Y. And I can substitute 23 in place of X here, so that's negative 23 plus 75. 52 student tickets were sold. So I can express my solution this way: 23 adults and 52 students attended the play. Okay, so here is a summary slide of what we've been talking about today. When we solve by substitution, it's helpful to write one of the equations as Y equals something or X equals something. We substitute the expression for the variable from step 1 into the other equation of the system. We then solve that equation for the variable. We substitute the value of the variable from step 3 into one of your original equations to find the other unknown. And we like to write our solution as an ordered pair X comma Y. So I have some practice problems for you to try. And we can start with solving a system of equations, both written in terms of Y. That's similar to example 1 in the video. And example B is similar to example 2 in our video.